Hello, in this video we're going to go over dividing exponents. So this is using the division properties of exponents to simplify our expression. And so before we get started, a couple of things that we have to make assumptions about. The first thing is anything divided by itself, like a over a, is going to equal 1. And so that's a really big assumption that we use a lot with these, and that way we can simplify faster. The other assumption is that the variables should not equal 0. If they equal 0, all of these can become invalid very quickly. You get a lot of dividing by 0, which we can't do. So we are still going to expand for dividing, but we're going to expand and then we're going to use the fact that we know anything divided by itself is 1 in order to simplify. Okay, so we're going to start. I'm going to expand out. This is a to the 5th divided by a to the 3rd. And so I'm going to expand out the a to the 5th for 5 a's, and then I have a to the 3rd in the denominator. And so what you can do after you expand is you can take the fact that you know that anything divided by itself is 1 to simplify. So but I can almost even like think about us crossing out. So if we have a over a, this just turns to a 1. A divided by a is 1. And then this a divided by a is 1. And this a divided by this a is 1. And once you get to that part, you'll notice that there's no more a's in the denominator. And so now we have simplified it fully. So you want to continue to simplify until you run out of variables either in the numerator or the denominator. And so what we have left is we have 2 a's left in the numerator. So we have a to the squared, or to the second power. And then we have nothing left in the denominator, but remember that there's always kind of these invisible ones that are floating to the left of our variables. And so for that, it would just simplify to a squared. Okay, and so we're going to practice this a good amount of times. We're going to use a couple of different variables and a couple of other things as well. So for this one here, if I expand out the numerator, I'm going to get 2a b's over 4a. And so you can see right now that you have 1b in the numerator, so that's actually not going to be able to simplify with anything because there's no b's in the denominator, but I can simplify the a's. So a divided by a is 1, so I'm going to go ahead and simplify that down to 1, and then I'm going to simplify the second a down to 1 as well. And so what we have left is 2b in the numerator and then 4a in the denominator. So I'm going to write that down. You can actually simplify it a little bit more. But because this is a fraction here, we can actually simplify that as well. So 2 over 4 just simplifies to 1/2. And so what we can do is go ahead and simplify that part of it. So you get 1 over 2. And we don't actually have to write the 1 because 1b is the same thing as b. So we can just write b for that. And so this would be our final simplified product here. Okay, we're going to do 3 more, just kidding, of these. They get to be really repetitive, so as you're working on it, you have x to the second, y to the third, over 10x, and then y squared. So I actually like to simplify the whole numbers to start. So I'm going to go ahead and simplify the 4 over 10 to, let me just like write it in pink so I can see it. I'm going to simplify it to 2 over 5. And so that kind of gets rid of that part. And then I'm going to go ahead and do the same thing, x over x. And now there's no more x's in the denominator, so I can move on to the y's. So I have a y here, a y here. That's 1. That's 1. And then now I've run out of y's as well in the denominator. And so now I can go ahead and write my simplified version. And it kind of gets tricky sometimes because it's like, where is everything? We have a 2, an x, and a y left in the numerator. And then we just have our 5 in the denominator. And so it would just look like that. Okay, a couple more. All right, let's look at this one here. -2, 3 a's and a b over 5 a's and a b. And so for this one here, -2, that doesn't simplify with anything because there's the only number in the denominator is a 1, that like kind of invisible 1 right there. And so we can go ahead and just cross out our a's. That's 1. Anything divided by itself is 1. So these are all turning into 1. And now I've ran out of a's in the numerator. So I no longer have any more a over a's. And so then I just have b over b, which can simplify as well. And now I'm just going to go ahead and write what I have left. So I have -2 in the numerator. And then the only thing left in the denominator I have is a squared. And feel free to like roll back to these videos if you're working on it and you're like, what? Because that's why I've made them free. It's kind of nice. Okay, so 7, and then I have x to the 3rd y squared. And then I have 14, 4 x's, and 2 y's. And you'll definitely start noticing some patterns. And so some of you are going to start skipping steps eventually, and that's fine. But initially, it's really good to practice just expanding, simplifying, and then noticing kind of some patterns. We'll talk about that after I simplify this one. Some patterns that we can notice from the beginning. All right, so the first thing I'm going to do is simplify this guy. So I'm going to simplify it to 1/2. And then let's see, I have x over x, x over x, x over x. So now I've run out of x's in the numerator. And then I have y over y, y over y. And so I have no more y's in the numerator or the denominator. And so all I have left in the denominator is a 2x. And there's nothing left in the numerator. Everything has been simplified out. So I have to put a placeholder in, though. There's not a number in the numerator. You have to write a 1 in. So that way it's not just like this weird line and 2x underneath it. You got to show that the 2x is in the denominator. And so you get 1/2 x. So some things you might be able to look at when you start looking at some patterns on these guys is this one was x to the 3rd over x to the 4th, and we were left with 1x in the denominator. And so you can kind of take a look at some of the patterns that you'll notice on those. For this one here, the y squared over y squared, anything divided by itself is 1. So it makes sense that that totally disappeared because y squared divided by y squared is just going to equal 1. And you can even look like at these kind here. We have x squared over x, which simplified to x in the numerator. And then we had y to the 3rd over y squared. You'll notice wherever you have more, like a higher exponent on that variable, that's where the leftovers are going to be. So if you have more on the top, like in this case, then the y's are going to remain in the top. If you have more in the bottom, like on this one, we had 2 a's in the top and 3 a's in the bottom, you're going to have the a in the bottom. So it just depends on kind of where it's located at the initial problem.